So in this one, let's talk about how to approach system design. Let's say you are let's say someone has thrown a problem at you. How would you approach that? Because it seemed overwhelming because there are so many components, so many things to decide, like what should be the approach to solve anything. So these are some of the things that I have always done throughout my career whenever I am designing any system. So let's start with the first one. That first understand that system design is extremely practical. So whenever you are designing any system, think in a very realistic manner. Think if you are the one who are building it, who are going to code it out, right? How would you design it? Instead of just drawing boxes for the sake of it, that's not a good way to do it, right? So think of it in a very practical way, and then you tackle one problem at a time. So the way I put it is I say that take baby steps no matter what. No matter what you have at hand, take really small baby steps and just go small one step at a time, and eventually you'll build a very good system. So there are 4 or 5 steps that I do, and this is how I recommend people to approach system design. First of all, understand the problem statement. One of the most important things to do over here is have a very good understanding of the problem statement, because if you don't have an understanding of problem statement, it's very easy to go in random directions. You are not focusing on the problem that needs to be solved, but you will start extending system into different random direction, and that's not what you should do. Whenever you are given a problem statement, understand what you are supposed to do. Understand the constraints of the problem statement. For example, if someone says, hey, let's design a tiny URL, let's design a URL shortener, which would handle 100 million requests per month. Right? You'll say, oh my God, 100 million requests per month. You are supposed to only handle 100 million requests per month. But if you are building system that handles 1 billion requests per month, it's easy to digress. Right? You would be doing over engineering when you're designing the system, because when you are given a certain constraint and when you live within that box, you will design a highly optimized system. And more often than not, if that system is highly optimized, be it 100 million, be it 200 million, be it 1 billion, some small changes here and there and you would be able to handle that scale. But it's very essential for you to limit yourself into the constraints that you have. Ask those critical questions to yourself that, hey, whatever you are designing, how you are designing, what are the constraints, what are the core features that you definitely want to have, and draw boxes around it, that you don't have to digress from those things. Right? That's really important. So build a really solid understanding of the problem statement. That is step 1 into approaching any system design. Step number 2 is you break the problem statement down into components. It's really essential. So for example, let's say someone tells you, hey, let's design Facebook. Now, when someone throws a problem at you that you want to design something as big as Facebook, the first thing that should come to your mind is, hey, what are the features of whatever I'm designing, in this case Facebook, right? Instead of getting overwhelmed by it, it's really important to break it down, because no one can tackle entire Facebook in one shot. It's really important to split that into multiple almost mutually exclusive mutually exclusive components. For example, it could be components, it could be features. For example, I'll give an example to make it much more clear. So let's say if you'd say, hey, design Facebook, you would say, hey, there would be one component that would take care of authentication. One component would take care of notification. One component would take care of feed, right? I just took 3 simple features that we use, big enough to be its own microservice, right? And then we tackle one at a time. So if the problem statement is big enough, like Facebook, split it into features. Right? This is the feature 1, authentication. I need notification. I need feed around it. Right? Once you have it, then you pick one at a time and you go deep into it. That, hey, let's pick authentication and go deep into it. Or let's pick feed and go deep into it. Right? So that's step 1. That if the problem statement is big enough, you break it down into smaller components and then you tackle one at a time. Right? when you are picking up a component, point number 3, you dissect that component and then you go deeper into it. That hey, let's say I want to pick feed for implementation. In order to implement feed, what would I need? In order to implement a feed, I would definitely need one web server who is serving the feed, that whenever a user comes online, user would make a request, web server would talk to the database, gets the feed and sends it to the user. That's the bare minimum that you have to do. So you need a web server. We are still not designing it, but we are just breaking it into smaller components, smaller quote unquote subcomponents if we require, right? So we need a web server, we need a database. But now if you think about it, we just solved reading part of it. What about who would write into that database? So you need a generator who is generating the feed for you. You don't know how, you're still not decided on that, but you have just drawn a boundary that if web server is the one who is serving the feed from the database, there has to be something that is putting in the database, right? So what we do, we define generator that is putting into the database. So this way you just drew the line around it, right? Once you become basically acquainted enough, once you've designed enough systems, you'd realize that, hey, it's not just about generator, but let's say if my feed, I might want to aggregate my feed. Let's say there are a lot of posts which I can aggregate into one post, or I can filter things out to optimize. So maybe an optional aggregator, which is aggregating feed for you, or rather filtering it out things for you and whatnot. You may just add aggregator around it. But if you're not sure, and I deliberately added this, if you're not sure what the responsibility of this would be, just skip it. It's better to not draw boxes for the sake of it. Like even while I was explaining, I deliberately wrote this to convey this message that, hey, Arpit seems not so confident on what the responsibility of this aggregator would be. So it's better to skip that out. We know we need web server to serve the feed. We know we need generator to generate the feed. We are not sure, we just came up with a fancy word called aggregator and we added it. But we are not sure what it would do. So when in doubt, remove that part. Because once you build, or once you go deeper into each of this subcomponent, you realize, hey, this is what we will definitely need. And then you add that, right? So this is what structured thinking is all about. So when in doubt, skip that, right? Once you go deeper, you realize that, hey, something like this needs to be there, then you add it, right? So drawing boxes for the sake of it is not good, right? Once you know what boundaries you would want to draw, what would be the clear set of responsibilities for each one of the component that you have, that's when you know that, hey, I need this. Everything else can take a step back. So in this diagram that I have, I'll not propose anything around aggregator at all, because I'm not sure what the responsibility is all about. Drawing for the sake of drawing, not a good idea, right? Okay. Now for each subcomponent that we saw, because being engineers, we need to dive a little deeper into it, right? So what would this web server be? What tech stack would it have? Would it be Python based, Java based, Node.js based, whatnot? Which database would we pick? How would this generator generate the feed, right? Those details needs to be there. So now what the next step would be, once you know that you have been, like, you have attained enough depth, that now it's time to make those technical decisions, which is where you go into making these 4 technical decisions. For any and every component that you have, these are the 4 key things that you need to decide on, right? We'll cover each one of them in very much detailed in coming videos, but I still want to just sprinkle those thoughts out on you. First technical component that we would have to think about is database and caching. Anything and everything around storage. How are you storing the data? Do you need caches? If you need cache to make things fast, where would it lie? How would components talk to that? So first key decision that you would take in a subcomponent is around database and caching. So storage. Second is around scaling and fault tolerance. So how would a web server scale? Because if there is one server and if I get 1 million users, one server will not be able to handle it. We need to have multiple servers, put them behind a load balancer. Those decisions would need to be there, right? Then about fault tolerance. What if my database crashes? What is my what is my strategy for my system to recover from this failure, right? Really important. So when you go into those details around scaling and fault tolerance, this should be for every single technical thing that you are adding. Think on those lines that, hey, how would each component scale? How would each component be fault tolerant? Third is most important, which is asynchronous processing. We'll go into details of messaging queues and messaging brokers, but just to give you a glimpse of it, asynchronous processing is something that you are not doing right away, but you are pushing a message for a consumer to pick up and do on their own. It's like you telling someone that you are, like, for example, you would want to do some task. You are not doing that task. You are asking your friend to do it for you. You delegated that task to your friend. You are not worried. You know your friend would do it for you. You are just handing him or her the task that needs to be done. Right? This is what asynchronous processing is. Right? We'll go deeper into what asynchronous processing is, but this is the idea. So for anything, for example, if my web server, or rather for me to generate the feed, does it need to be done while I'm running the app? When user makes a call, should I generate my feed then, or should I have it pre-generated? Right? Because imagine you logging onto Instagram and Instagram taking 5 minutes to load the feed because it is generating on that time. Not a good idea, right? So you'd want to do it in an asynchronous way, that behind the scene, it is generating and keeping the feed ready for you to just scroll through it, right? This is asynchronous processing, right? And the fourth one is around communication. How different components will communicate with each other. When I say communication, this is technical detail. TCP, UDP, HTTP, WebSockets, gRPC, whatnot. How would communicate? How would web server and database talk to each other? How would generator service and web service, like web server, may want to talk to each other? How would generator read from other data sources, for example? Communication part. Web server, or rather, WebSocket, gRPC, HTTP1, REST endpoints, those parts, right? These are the things, these are 4 critical things that you would be looking at into all the subcomponents that you design. Because that's when you know that you are designing a good system, right? Okay, now that you went into details of each of this, but now you might find a need that, hey, web server is decent enough. I know it's like I literally just have to start writing code to power a web server, maybe Flask, Django, Spring Boot and whatnot, right? But when it comes to generator, I'm not sure, like, I'm still know it better. Like I would still need to split this generator into something more, because this generator is not a standalone thing. It would need to read from other places, right? So that is where what you do is you now start to think of that, hey, do I need to split my generator into multiple even smaller components where each one having its own set of responsibility? When we design other systems, you would get a very nice idea of it, but try to understand what we are discussing here. That if you find a need to split a component which is generic enough as a generator, that how do you actually do it? Which is where I say that wear the hat of an engineer and think, if you are implementing it, how would you write code to implement a generator? How would you actually implement it? When you go into those details, you would find out that, hey, I might need something that is reading from other services and merging it. And maybe having some database where you're storing some temporary information, and this becomes your generator. So a generator itself consists of 2 or 3 components, right? Or other sub components, right? And it needs interaction from, let's say, post service, recommendation service, and follow service, right? Someone who knows that, because for me to generate a feed, for a feed generator to generate a feed, it needs to know who you follow. It needs to use information from recommendation engine so that it can recommend you content that you are more likely to like and share and subscribe and whatnot. And then a post service to populate the details of it, right? So that is where information from the followers, like the people you follow, the recommendation that the system generated, and the post service, you would merge all of them and put it into feed database, which is used by your web server to do it. right? When you start thinking of implementation, you realize, hey, these are different things I would need to interface with, which is where I say, approach it in a very structured way. It's always better to go things top down when you are given a very big problem, like Facebook, design Uber, design Tinder, right? Start with features, break each one of them down and solve it. If you are given a very specific problem, start bottom up. Start with designing database and whatnot. So there are typically two ways to do it. Big given problem, start top down. Small details or rather very focused problem, start bottom up. It's typically how most senior engineers approach any system in general, right? So yeah, that's all what I wanted to cover. This is all about how to approach system design. And again, just to reiterate, it's very practical. Every single system design question, every single system design that you are thrown at is extremely practical, and it needs to be approached in a very structured way. It's not something which is chaotic. It's not something that you can mug. It's something that you need to build that intuition, right? And I hope I showed you one of the ways to build that intuition around it. When we design more systems, you'll get very nice idea on how we are approaching one problem at a time. And yeah, this is what I wanted to cover in this one. I hope you found it interesting. I hope you found it amazing. That's it for this one. I'll see you in the next one. Thanks a ton.